In Python, calculating the exact time difference between two dates is crucial for mastering performance benchmarks. For instance, tracking a script's precise start and end timestamps allows us to measure its execution speed flawlessly. To do this, we rely on the incredibly powerful time delta object, which captures elapsed or remaining time perfectly. Let's look at an example. First, we will import from the datetime module, bringing in the highly useful datetime class. This class unlocks essential features, like fetching the exact current time right now. Now, let's set a deadline. We will use the end of the year, the 31st of December, 2026. Our goal is to compute exactly how much time is left. Let's check out our very first calculation. Deadline minus today. Once executed, look at the result. It prints out a clean duration, 198 days, followed by 7 hours, 14 minutes, and 48 seconds. It calculates all the way to midnight on December 31st. Since our current time is 1645, we can observe how dynamic this calculation is. If I scale the year up to 2036, notice how the total number of days jumps. The scale continues to grow seamlessly. Let's push it further to 2056. As you can see, the output consistently structures itself by days, hours, minutes, seconds, and microseconds. Days remain the core foundational unit. This is a vital distinction. Now, let's examine our second scenario, where we benchmark a program's start and end times. We'll run a quick loop to measure execution speed. And here's the precise duration. Notice that this output omits the days segment entirely, displaying only hours, minutes, seconds, and microseconds. Let's inspect the underlying data type by printing out the remaining variable's type. As expected, it belongs to the datetime module's time delta class. If we run the same check on our loop duration, it confirms it is also a time delta object. Remember, time delta inherently tracks everything: days, hours, minutes, seconds, and even microseconds. When a difference spans less than a single day, it cleanly hides the day count to keep output sleek. This smart formatting is incredibly useful to remember. It makes measuring execution gaps in Python an absolute breeze to implement. Keep in mind, time delta is the core class. It prioritizes days because they are a reliable, constant unit, making them perfectly predictable to calculate. Unlike months or years, which constantly shift, why does Python default to days? Because a day is always fixed. Months fluctuate between 30, 31, or even 29 days. And years vary due to leap years. Days avoid all that chaos by sticking to a standard, fixed unit. It remains precise. That is the magic of time delta and its foundational format, giving you total control over internal application timing. Just use the standard minus operator to fetch your time delta and unlock a world of precision.